All right, so this first warm up here is just statistical stuff that maybe you've seen through your time at Ichabod Crane or whatever school you attended. Um, some of this stuff we'll be going over in more detail during this year. Some of this stuff I kind of expect you to already know, but it's just kind of a way to get us back in the mindset of math and back in the mindset of statistics. So, question one said, what is the five number summary for the box and whisker plot below? What does each number represent? So, presumably, you made these back in algebra. If not, again, no worries. It is something we'll be talking about this year. But the five number summary is basically these five numbers right here, all right, that are marked on the graph. So for this one, it would be 5, 8, 10, 17, and 19. All right. And those numbers represent the minimum value in your data set. This is quartile 1, and we'll define quartile down below in a second. This would be our median. This would be quartile 3, and this would be our maximum. All right, so a box and whisker plot is just a visual way of showing those five numbers. Okay. All right, describe each of the terms below. So again, some of these might be familiar, some of them might not. That's fine. Mean is one that usually people are pretty good with. It's basically just the average. So your mean value is another way of saying pretty much calculate the average. We have the median value, which is usually just the middle of the data set. Right? We have the mode, which is whatever value occurs the most. Now, in this class, we'll actually be talking about mode as sort of peaks in the distribution. And again, we'll talk about that more as we go. But instead of just always saying, oh, well, this is the one value that there's the most of, we'll be looking for what are called like localized peaks in a distribution. All right, now quartiles, if you see quart there, hopefully you think 4, because it's basically the three numbers that divide data sets into 4 equal parts. All right, so usually we talk about quartile 1, quartile 2, which is also the median. So quartile 2 and the median are the same thing. All right, Q2 and the median, those are the same thing. And quartile 3. So quartile 1 is basically like 25% of the way through the data. Quartile 2 is 50% of the way through the data. Quartile 3 is 75% of the way into the data. So if you just kind of like visually think of this as your data set, you've got Q1, Q2, and Q3, and these numbers divide the data set into 4 equal parts, part 1, part 2, part 3, part 4. All right. Range. All right, so the biggest thing to remember when we're talking about range in a statistics class is it's not like, oh, the range is from 5 to 10. When we use the word range in a statistics class, we're talking about a specific calculation. So I'm going to write here that it's a single number. All right, and that number is found by doing the max subtracted by the min. All right, so just if I ever ask for the range, make sure you're not saying, oh, it goes from 2 to 10. Make sure in that same example, you'd be saying the range is 8 because 10 minus 2 equals 8. All right. And then standard deviation, even if you're not sure how to calculate it, you've probably at least heard it before, heard that phrase before. And it's basically a measure of how spread out your data is, your data set is. Yeah, let's go say data set is. All right. A more specific way, and something we'll talk about later, is that it's effectively the average distance from the mean. And again, we're going to spend a lot of time on standard deviation, so we'll talk about that more later. But it's basically the average distance from the mean. All right, so if we flip this over to the back, all right, what is the range of possible values for a correlation coefficient? All right, so maybe you saw this, maybe you remembered what it was, maybe you didn't remember what it was. Correlation coefficients are usually associated with those like clouds of dots. All right, so sometimes you have a cloud of dot going this way, or sometimes you have a cloud of dots going this way, or sometimes it's like just a random cloud of dots. And what the correlation coefficient kind of tells you is the association between those dots. And the closer those dots are to a straight line, the larger your coefficient. And then positive or negative kind of relates to the slope that those lines are or those points are making. So the possible range is -1 to +1, where -1 would be like a bunch of dots and a negative slope line, and +1 would be a bunch of dots and a positive slope line. And then 0 would be something like this, where there's like really no line or shape or direction to the points. All right. So when a fair coin was tossed 10 times, it landed heads up the first 7 times. What is the probability that on the 8th toss, the coin will land tails up? All right, so it landed heads 7 times in a row. What's the probability on the 8th toss that it will land tails up? This is what we call a trick question. A coin doesn't remember what it did on the previous flip. Each test is what we call independent. So it doesn't matter that it landed heads the first 7 times up. The probability that on the 8th toss the coin will land tails up is the same as it is on every single toss, which is 1/2. Okay. The probability that the Cubs win their first game is 1/3. The probability that the Cubs win their second game is 3 out of 7. What is the probability that the Cubs win both games? All right, so when you have 2 events like this, and we have those probabilities there, we've got a 1 in 3 chance of winning the first time. We have a 3 out of 7 chance of winning the second time. What we're going to see, and we'll do more with this later in the course, but you may have seen this sort of thing before, we just multiply those 2 probabilities together, and that'll give us the probability of winning both games. So 1/3, 1 times 3 is 3, 3 times 7 is 21, 3 over 21 is 1/7. So the odds of winning both games are 1 out of 7. All right. And this is going to deal with we'll deal with like conditional probabilities and disjunctions and conjunctions, and that's where all this sort of stuff will start to come in. All right, Mr. Vona has 10 boys and 15 girls in a mathematics class. If he chooses 2 students at random to work on the blackboard, what is the probability that both students chosen are girls? All right, so this is kind of similar to the last question, but there's just sort of like one extra wrinkle that we have to be on the lookout for. All right, so if there are 25 people in total, 10 boys and 15 girls, 25 people in total, and 15 girls, the probability that the first student we choose is a girl is 15 out of 25. All right, this would be the first student. Now, the probability that the second student is also a girl is no longer 15 out of 25 because we've already selected one of the students. All right, so assuming the first student was a girl, the odds that the second student is a girl, there's only 14 girls left because one of them was already picked, and there's only 24 students left because one of those was already picked. But again, just like above, we would sort of multiply those two together to get our answer. All right, so 15 times 14 is going to be 210. And then 25 times 24 is going to be 600. And then we can reduce that down to 7 out of 20. All right, so again, just stuff that you've probably seen things like this before. So I'm just kind of trying to jog your memory a little bit. And again, we're going to go into a lot of this stuff in probably more detail than you did previously. All right. A school offers 3 classes of math and 2 classes of science, all of which meet at different times. What is the total number of ways a student can take a math class and a science class? All right, so you might have done these where you kind of made tree diagrams. So you might have said, oh, if we pretend the 3 math classes were like algebra 2, geometry, and then if we said the science classes were like, let's just say chem and bio. All right, chem, bio, chem, bio, chem, bio. That's one way of doing a problem like this and saying, okay, so in total, there are 6 different branches that I can go down. So there are 6 different ways that I could take, 6 different arrangements that I could come up with. This is actually called the counting principle. And quicker and easier than making one of these charts is just recognizing that 6 is equal to the 3 math classes times the 2 science classes. All right. And this relationship holds if it had been 5 math classes and 3 science classes, there would have been 15 options. But instead of making a tree every time, you can actually just multiply the number of possibilities, and that'll tell you the total number of options. All right. What is the difference between a permutation and a combination? All right. So with a permutation, the order in which you do things matters. And with a combination, the order in which things happen does not matter. And most of the things that we do in here will be combinations. So we'll mostly be using combinations for the stuff that we do. But it's when you're calculating probabilities or the number of possibilities. And when you're looking at permutations, you're saying the order of those possibilities matter. When you're saying combination, you're saying the order doesn't matter. All right. And then last but not least, what is the difference between a histogram and a bar graph? All right. And a lot of times what I get here is like whether or not the bars are touching. And technically that's right. So with a histogram, the bars touch. With a bar graph, the bars don't touch. But we are going to be a little more exact with this. A histogram is usually for quantitative data. Whereas a bar graph is used more for categorical data. And again, those are 2 things that we'll spend some time on in this first unit, going into more detail, examples of each, and then what sort of tools you want to use based on the data that you have. All right, so again, this warm-up, not stuff you have to know, but stuff that you may have seen before. So you can kind of think of this as just sort of jogging your memory, and also sort of a preview of some of the stuff that we'll be looking at in more detail throughout the year. All right, great. Hope this was helpful.